All right, guys, at this point we are nearing the end of the quarter here. So I think I'd mentioned this in class. We're going to be condensing down the rest of this unit. So whereas when we were working with our sine and cosine functions, we kind of looked at it in three different aspects: graphing, finding the equation, and then using those for applications. So as we wrap this unit up to try to fit it into the quarter, you're going to see all we're really going to focus on are graphs of secant, cosecant, tangent, and cotangent. Secant, cosecant are actually the easiest of the remaining four because they're based off the functions we already know in sine and cosine. So today that's what I'm going to do with you. I will discuss this in class if there's any questions we have on it, but again, I'm expecting that most of the learning is going to be done here. So please make sure you pay close attention to this. This is, again, where the lesson's being taught, but if you have questions on it, please write down your questions so that we can go over those in class. So starting off, I'm going to go over the parent graphs for secant and cosecant. And again, if you know sine and cosine, then you will know how to do the parent graph for secant and cosecant. So here's how cosecant is going to work. First off, a reminder, cosecant is nothing more than 1 over sine. So a couple things we need to note, and you'll see that as we go through the graph. There will be times, because sine does equal 0 at a few different spots, there will be undefined values on this graph. When there are undefined values, where in this case you have a 0 in a denominator, we'll have vertical asymptotes. So you will see that when we do the graph. I'll show you how this kind of all looks, but just be aware of that. So as I go through this, I am going to kind of do the normal thing where we do, amplitude, we do period, we do phase shift. Now in the parent graphs, a lot of these will be 0, but I'm just going to walk you through that whole process. Vertical shift, and then domain and range. So here we go. First off, I want to let you know when we go through the graph, the amplitude, and you don't know this yet, and that's fine, but I want to kind of let you know now, and we'll show you when we do the graph, but there's not going to be an amplitude. Your amplitude is going to be none, and you'll see that when we do the graph. It's not actually going to be a wave. It's based off a wave, but it is not a wave. The period, however, is the same. So the period is going to be 2 pi. So it is based off a sine, and that period, that repeating motion, is the same. In this case, we do not have a phase shift when we're doing our parent graph. We don't have no vertical shift. But I will need to talk about domain and range, and I'd rather do that when we look at the graph. So anyway, what we do with our period, just like when we do our sine and cosine graphs, we're going to do our Patrick interval. So I'm going to go 2 pi times 1/4 to get my 4 quadrants and get that interval for the x-axis. So that's going to be pi over 2. And again, this is just the parent graph. I'm just walking through the process. You can probably figure that interval will be pi over 2 anyway, but here we go. Coming back up here, I'm now going to label the Patrick interval, which is pi over 2. I'm going to do that for at least one period. So I'm going to go pi over 2, pi, 3 pi over 2, and I'll go out to 2 pi. I'll also go backwards one just to show you the pattern the other way. But again, it's just a pattern. And from here, we are going to graph our sine graph, and I'll explain what we're going to do with this. So when we graph our secant and our cosecant, in this case cosecant, it is a reciprocal of sine, which means we start by drawing what's called a reference graph. That reference graph is going to be sine, and it's going to work the following way. We're going to label our points as if we're drawing sine. So I'm going to start at 0, 0. We're going to go up to 1, back to 0, down to -1, back to 0, and so on. I'll even go backwards 1. But when we graph sine, we do this. We graph it as a dotted line because this is not our graph, but we are going to use this graph as a reference for cosecant. So again, this is not our graph, it is a reference graph. So understand how this graph is going to help us. Well, as my values for sine reach these special points, I'll go through each special point right here. certain things are going to happen to my graph. So I'll start, for example, with the sine of negative pi over 2. So we're going to go right here. Okay, so the sine of negative pi over 2, or the cosecant, let's say, sorry. The cosecant of negative pi over 2. You don't have to write this, I'm going to have to erase it, but you can write it if you want to have these notes to go along. This is equal to 1 over the sine of negative pi over 2. Well, the sine of negative pi over 2, we can look at our reference graph, we can see that that is negative 1. So you'll see how the cosecant of negative pi over 2 is the same as really just sine of negative pi over 2. They're both equal to negative 1. So my first point on my cosecant graph is that point. And that's how that reference graph is going to help us, where all those, the top and bottom values of my graph are going to be the same. Again, I can come up here and I can do the same thing. If I did the sine, I actually do the cosecant. So the cosecant of pi over 2, that's equal to 1 over sine of pi over 2. And again, that's 1 over 1. It's that point right here, our reference curve tells me. So all these points at 1 and negative 1, those are always going to be the same on our graphs. So I have these points. So that's where our reference graph helps us there. The tops and bottoms of our waves are the points on our secant and cosecant curves. Now the other points are going to be these points right here. All these points where we get 0. So I'm going to use pi for an example. I'm going to find the cosecant. Oops, can't spell. I'm going to find the cosecant of pi. Well, the cosecant of pi is 1 over the sine of pi, and sine of pi is 0. So we get an undefined value. So what you have to understand and remember from when you back in, well, this was what, last year, maybe for some of you, when you have a fraction that is equal to 0, we have what's called a vertical asymptote. And what that means is it's a imaginary line that your graph will not touch, and it's going to look like this. So we got a vertical asymptote at all of these zeros. So everywhere you see a 0, you are going to have a vertical asymptote. And all that happens is your vertical asymptote is a line that your graph will approach. It won't touch, but it will approach it. And what that means, like if I plugged in, say, this point right here on my sine curve, this would be 1 over, if I'm doing cosecant, a really small number. And again, if you know how math and numbers work, you recognize this. You'd say, well, 1 divided by a really small number is a really big number. You can kind of see it right there. So what happens is when sine gets smaller, cosecant gets bigger. So your graph is going to do this. It's going to take off towards those asymptotes. It's almost going to look quadratic, like a parabola. The only difference is a parabola does have a domain of all real numbers that expands forever. This one doesn't. It is restricted by those vertical asymptotes. So down here, this would go down forever because, again, your sine values would still be negative. So you would have 1 over a negative number. Mm-hmm. And if you only have half a curve, just draw that half. That's fine. Just draw whatever piece you have approaching that vertical asymptote. So if you see, you really, when you're doing cosecant, graph sine. Once you have sine, just use those reference points to help you draw your cosecant curve. So I'm going to show that as I go through here for the next one. But before I do that, I do want to talk about domain and range. So the range, let's start with the range. Now the range, we start at negative infinity. This graph goes down forever. Now this is going to be a combination or a union of two sets because there's two sets of values that our range is found in. It's found down at the bottom and up at the top. Okay, we got this little gap in between where there is no graph whatsoever. Again, that reference graph is not my graph. So we need to fill in those two regions, the region where it goes down forever up to -1, and then from 1 to infinity. So it's going to look like this, negative infinity to -1. We do touch -1, and we're going to do a union of two sets. So that's going to be that set and the union of this second set. That also means like this region or that region. So it's going to then jump to 1 and go up to infinity. And that is going to be your range for your parent function. And you just skip over all those middle points from -1 to 1. All right, your domain. Now your domain, we have to write it. We can't, this graph goes forever, okay? And as it goes forever, it's going to have an infinite number of restrictions. So if you want to write the domain for something like this, what you need to do is write, instead of writing what x is, we're going to write down what x isn't. So we're going to go x. We can't really use set notation here. So before I just start writing it again, set notation is not going to work. Otherwise, you'd be writing it forever. It just never stops. It has all these different regions. There's an infinite number of these regions, so I can't just keep drawing all those different sets for an infinite number of sets. I can't. So I have to kind of look at the pattern and write an equation that represents that pattern. That's the only way you can represent this. So I'm going to write this again as a pattern. Now instead of saying what x is, what I'm going to do is I'm going to say what x isn't. That's the easier way to write this, the pattern, because I can see a pattern for when these vertical asymptotes appear. So I'm going to write down where all those vertical asymptotes are, and if you look at each vertical asymptote, notice it repeats every pi units. Now again, if the period changes, that unit will change, but right now, parent graph, it repeats every pi units. So x, oh, and by the way, the first interval, or the first time it's undefined, is at 0. So I'm just going to go x cannot equal pi times k. Now we have to make sure that k is an integer for this to occur. But the best way to really represent that domain is basically say, well, it's all real numbers except when x is equal to pi over k. So it's everything but that. So you can write it out loud and every single time, or you can just say x cannot equal pi over k. That's fine, because then it's everything but those numbers. So it's a little different way of labeling domain, but it's because of the uniqueness of that graph. We have to find some way to represent it, and that's usually the best way to do it. Okay, so sorry, I'm moving around a lot. That is going to be your parent graph for cosecant. Now for secant, I'm going to do this a little bit quicker since we've kind of seen the concept. So secant, I just want to remind you, we are just going to go ahead and graph cosine as our reference. Again, that's what I want you to remember on this. We're just going to graph cosine and then use that reference curve to draw secant. So I will go down the line here again with our amplitude, our period, and so on. So phase shift, vertical shift, domain, and range. And again, this one I'll go a little bit faster. First off, there is going to be no amplitude on this. I didn't get to that last time, but notice it's not a wave. Don't get confused. That's not our graph. Our graph's what I have in red. Notice that is not a wave. It doesn't have a height. It goes forever. That's why there's no amplitude. So don't get that confused. If you see a 1, oh, there's a 1 out front. That's my amplitude. Not for secant and cosecant, because it's not a wave. So there's no amplitude. There's no there's no period. There's a period. Your period, in this case, I have one that I'm going to do that's in degrees, but I'm doing these in radians right now. So this is going to be 2 pi for your period. Phase shift is none. Vertical shift is none. And then we'll do our domain and range here in just a second. Actually, I can do the range. It's the same as the last one. So -infinity to -1 with the union of 1, positive 1, to infinity. And like I said, we'll just do the domain once we graph this. So a couple things. We are graphing our cosine curve. So I'm just going to go ahead and put these points on here. I'm going to count by pi over 2's. So we'll go all the way up to 2 pi. And I'll go backwards pi over 2 as well. Also, I'm going to go to 1, -1. And once I have all this labeled, again, all I'm doing is I'm graphing the cosine parent graph. So that cosine parent graph is going to start at 0, 1, then go to 0. And again, you just follow that cosine pattern. Once you have that cosine pattern drawn, connect it with the dotted line because it's not actually our graph. Do not draw it as a solid line, or I'm going to assume that you think that this is your actual secant curve, which it's not. Okay, so some things we can do now that we have all this labeled. Remember, whenever the cosine curve crosses the x-axis, we have a vertical asymptote. So you can draw your vertical asymptote at every single zero of that cosine function. Also, wherever your graph touches at 1 and -1, and that's where your secant curve will also touch. And then we just approach the asymptotes. So you see, this is really more of a cosine graph than it is a secant graph. Most of your work is graphing cosine, and then you just connect those points. No matter what craziness we got going on, all that craziness is going to have to be dealt with as you're graphing cosine, not as you're graphing secant. So there we go. That's all we're really doing. So in order to get the domain, notice it changes here. So when I do my domain, instead of just saying x cannot equal, pi k, I'm going to have to start now at pi over 2 or negative pi over 2. It doesn't really matter, but I have to start at one of my asymptotes. I'm going to say pi over 2, but it doesn't matter which one you start at. It's pi over 2, and I'm going to say plus or minus, which I forgot to do over here. My apologies. This is going to be plus or minus because we're going to the right and to the left for infinity. So you're going to have to put that on both. So over here it's going to be pi over 2 plus or minus, and again we look at that interval. Now because it's our parent graph, you'll notice it's the same interval. You're going from negative pi over 2 to pi over 2, that's pi. So that's the interval between them. So you're going to go pi over 2 plus or minus pi k, and again k is an integer. Technically you have to say it every time. If you're on a test and we're doing a bunch of these, and if we ever get to that, just say it one time for all of them, that's fine. But anyway, technically k has to be an integer for that to work. Okay, so I have two of these I wanted to show you that deal with transformations, and that's your parent graph. You'll see it's exactly what we've been doing before. So that's what you'll be seeing here. If you need to see that one more time, I'll leave them both up so you can pause it. Okay. All right, so for A, we're going to go through this graph, graphing secant, and a couple things on this. We're going to fill it out just the same way as we did before. We just have some transformations this time. So I'm going to go amplitude, period, phase shift, vertical shift, and then domain and range. So that's going to be the process just like we've done before. Remember, there is no amplitude, so I'm going to just say none right now. However, for the period, this one, before I start this, I want to do one quick thing. I want to write this as 1/3 secant, and I'm going to pull that 2 out. When you do that, that's going to be x minus pi over 2. That's going to give me a proper phase shift. As opposed to doing c over b, you can just factor that out, and pi over 2 is your phase shift. So my period, as I go through this, again, the period is going to be 2 pi over b, and b is 2 in this case, so here's your period. Now remember, as you do this, when you find your period, I don't like to do it next to the period. I don't want you to I don't want me to be confused if that you don't know what your period is. So the period is pi. However, to find that Patrick interval, we're going to multiply that pi by 1/4. So that is our Patrick interval. That's what I will count as I go across on the x-axis when I do that part of the graph. All right, from here, my phase shift, I'm going to go right in this one, pi over 2. My vertical shift is none, and I will do the domain and range once I see my graph. So here I go. So for this graph, I'm going to, looks like my amplitude of cosine, which I'll be graphing for this one. If you don't remember that part, again, remember all this really is secant is 1 over cosine. So when I do my graph, we need to remember we're actually graphing cosine for this. And then I will fill in the rest of my curve. So I'm going to treat this like a cosine graph. I'm just going to do it as a dotted line, and then I should be able to graph secant no problem. So I'm going to start by counting by 1. I'm going to go up 1/3, and go down 1/3. Got my y values. Now I'm going to count my x values. I'm going to go pi over 4. 2 pi over 4 is pi over 2. Then I have 3 pi over 4. 4 pi over 4 is pi. I'll go a couple more because I already am going right. So I'll go 5 pi over 4, and I'll stop here at 6 pi over 4, which is 3 pi over 2. That should be good. And I'll just go to the right of the x-axis. I'm already going right pi over 2 anyway, so I'll be going backwards a little bit. So when I graph this, I'm going to start at my starting point, which is right pi over 2. That's my phase shift. And because I'm graphing a cosine reference curve, I'm going to go to pi over 2, 1/3, start at the top. And then label your other points. I'm going to go down and then back up. And again, this part of the curve should look like your normal cosine curve, starting up at the top and just following that wave, that pattern. And I'm going to go back a couple spots since I can and draw that piece as well. Okay, remember this is just a reference curve. This is not my graph. I need to put my vertical asymptotes in wherever you see this curve crossing the x-axis. So that's what I'm doing now. And finally, wherever you see this point at the top or bottom of your curve, you're going to put a point there because it does touch there. And we draw a graph. Make sure your graphs approach those vertical asymptotes. And we are kicking butt. Okay, so again, we got our graph. You got everything labeled. We need to find the domain and range. Well, we'll start with the range. The range goes from -infinity all the way to -1/3. Touch that point. Remember, it's a union of two sets. Now we're going to skip over all these middle points here. I'm going to jump all the way to +1/3. And that is going to go all the way up to infinity. So that's your range. Notice that pattern as we do that. It goes from bottom set to top set. Your range, find the first vertical asymptote, which in this case I'll use as pi over 4. If you use 3 pi over 4, that's fine. But I'm going to start there. I'm going to say x cannot equal pi over 4 plus or minus. Remember that part because I forgot it the first time. And I got to get this distance. So when I'm looking at this distance right here, if you don't know how to find the distance, subtract them. 3 pi over 4 minus pi over 4. I want to get the distance between the asymptotes. So that's 2 pi over 4, which is pi over 2. You also notice it's half your period if you haven't realized that yet. And that's the interval, the gap between your vertical asymptotes. So it's going to be plus pi over 2k. So again, I will say, again, k is an integer, just to kind of make sure you remember that. And that's your domain. It's an equation, basically. Okay? And I got one more here, and I'll kind of wrap up with that. Again, I figure you can pause the video if I'm going too fast. So I'm going to go on to our last one, which is in degrees. I didn't forget about the degrees. They're still here. We're going to go ahead and do the exact same thing as we do on all the other ones. We're going to go amplitude. I'm going to go period, phase shift, vertical shift, and then domain and range. Okay, so for this one, remember we don't really have an amplitude. Now our sine graph that we'll use as a reference, it will, but we don't have an amplitude for cosecant. Period is going to be 2 pi over 10, so that's going to be pi over 5. So there's your period. Remember, with your period, we need to multiply that by 1/4, so pi over 5, sorry, times 1/4. Actually, I said that wrong. I'll go back and fix it. My bad. I'm sorry. I'm in degrees. I'm confusing myself, and I'm not editing this video, so I'm just going to make my mistake. Okay, so this is going to be, 360 divided by b, which is 10. Again, your period is now 360 over b because we're in degrees. So I factor that out, a factor of 10, and I get 36 36 degrees for my period. A little bit better, okay? All right, now that I have that, my period is 36 degrees. Now let's cut that 36 into 4 pieces. So multiply that number by 1/4. Okay, so again, I did 360 over b, that equals my period. Then when I do my graph, I want my Patrick interval, so I'm going to multiply that period by 1/4, and we're going to get 9 degrees. That's my Patrick interval. Do not call that your period, please. All right, as we do that, our phase shift, it looks like I do not have one here, so I'm going to say none, but I do have a vertical shift. I'm going to go down 2. So I may have to talk about that when we do our graph because that's new. But also don't forget when I do my graph is that negative sign. I'm going to have to come back to that, but just please be aware of it. So here we go. Now this one's going down 2. I'm going to make just a bigger y-axis so we don't have any issues here. It will mostly be underneath it, but so I'll try to draw this up here. Okay, I guess I'll have to squeeze that in there, so that's fine. Okay, so I don't have a phase shift, that's okay. So I'm going to start counting by labeling my x-axis. I'm going to go by 9 degrees. I'm just doing that first, it doesn't really matter. I'm going to go 9 degrees, 18 degrees. I'm just counting by 3s, so 27 degrees, 36 degrees, not 360, 36 degrees, and I'll go backwards. I'll go back to -9 degrees as well. Alright, so that is my x-axis labeled. This one is going down 2, so I will go down 2 as well. So I'm at -2. And there's going to be a lot of dotted lines going on here. Just kind of deal with it, I guess. That's my midline. Alright, so I will go ahead and just get these points on here so we have them. Okay, so I got my tick marks. So when I do my graph, and so I went down to, and I have an amplitude of what normally would be 1, so I need to go up 1 and down 1. Again, I'm just thinking about graphing sine right now. I'm not worrying about the cosecant, so I'm going to go right in here. So that is going to be my range for this graph. It's going to be somewhere in there. Okay, all right. So that is ready to go. I have everything labeled. I'm just going to go ahead and get started. So cosecant, remember, is the same as 1 over sine. So I'm going to be graphing a sine graph. Okay. Now, one thing to be aware, this -2. Notice this comes after I do my sine function. So our zeros are going to be here. These are where our vertical asymptotes, whenever that graph touches that midline, my graph will have a vertical asymptote. And again, that's the reason is we do the sine and then subtract 2. So if it's undefined and I subtract 2, it's still undefined. So be aware of that as we go and do our graph. So I'm just going to go ahead and graph sine. So I'm going to start in my first point. I have no phase shift, and I'm going to start in the middle. Now, because this is negative sine, instead of going up, I am going to go down. I'll let that point there. So I'm going to go down to -3 and not up. Because again, it's negative cosecant. So we get our pattern this way instead. So I go down and then up and then down and so on. So again, your graph would look like this. And again, if I went backwards 1, I would just go to that point. And there we go. Now again, wherever this graph touches that midline, that's going to be a vertical asymptote. So I need to draw my vertical asymptotes. And it should line up with the 36. I'll just kind of make that bigger. And I got 1 right here on the y-axis. So I got to get in there as well. So remember, wherever that touches. Okay. Next up, my points, my top and my bottom points, those are going to be equal. So then you can just draw your graph, and it looks like this. Kind of, that's an ugly version of it, but whatever. Alright, so there's your graph. The last thing we need to do is our domain and range. Again, I prefer to do that after we've seen the graph. So your domain, that's going to be looks like it starts right here at 0. That's where your first undefined value is. So I'm going to say x cannot equal plus or minus, and again, what's the interval? Well, this one's easy to tell. The interval is from 0 to 18 degrees. So it's going to be 18k. Remember, k is an integer. Okay? That's your domain. Your range, again, we do the bottom set and then the top set of values. So the bottom set will be negative infinity to negative 3. We include the negative 3, so put a bracket there. We skip over all these middle stuff because there's no graph there. And then I'm going to go from negative 1 to positive infinity. So there's your domain and your range, and that's going to be your graphs of secant and cosecant. Notice it's using the skills we already have. It's just graph that reference curve and then just, again, use your vertical asymptotes and your points and draw your secant and cosecant. It just really adds a couple steps to the end of your sine and cosine graphs. So with that, again, obviously, I'm going to want you to try this. So here's how we're going to do it. This will be sitting on eCampus. If you go into Module 2, you will see this. Blue Book, you'll see Blue Book Chapter 5 is going to be located in Module 2. So what we need to do, you haven't done the Blue Book in a little bit, but you know how to use it. We're going to go to 5.4, and notice we have problems 30, 34, and 37. I'm only giving you 3 of these to try on your own. So once you try these 3, make sure when you do these 3, just like I did in the notes, I want you to label all those important values and give me at least 1 period of your graph. I will be grading one of these for correctness. So I just want to make sure you're aware I am grading one for actually being right. I know, it's crazy. So make sure you are checking that for correctness and turn it in on Friday. Okay, so again, you can work with, you have whatever resource you want. I don't care. I want you to figure this out. I want you to take that initiative. I want you to figure out how to do this. If that means you need to work with somebody, do what you need to do. But I want you making sure you, because again, guys, this is sine and cosine, okay? We've done sine and cosine with 2 steps. You should be able to take that step, that extra step forward now. We just took a test on sine and cosine and do secant and cosecant. So make sure you do these 3 problems. And I expect that those will be done by Friday. Again, with all the resources we have, it's 2017, you should be good. All right, so I'll see you on Friday. Make sure those 3 are done. Also bring your notes. I'll probably check those off as well. All right, good luck, and I will see you guys on Friday.